Hello and welcome. Today we're diving into a critical aspect of our clean energy future. How do we reliably integrate massive amounts of solar and wind power into our electricity grids? It's a huge transition, but renewable sources aren't like traditional power plants. They're variable. The sun doesn't always shine, and the wind doesn't always blow. This intermittency presents real challenges for the power systems we've relied on for decades. Think about it. Our traditional grids were built for consistent power flow from centralized plants. Adding large amounts of fluctuating solar and wind makes balancing supply and demand tricky. Rapid changes in generation can destabilize grid frequency and voltage. Plus, much of our existing grid infrastructure wasn't designed for power flowing back from millions of rooftop solar panels or handling huge power surges from remote wind farms. Accurately predicting renewable output also remains complex due to weather uncertainties. So how do we overcome these hurdles? The answer lies in upgrading to what we call smart grids. These aren't just power lines. They're sophisticated systems using digital communication, automation, and data analytics to create a more flexible, efficient, and reliable power network. Smart grids are essential tools for engineering a power system that can handle high levels of renewables while keeping the lights on. Let's look at some key smart grid technologies making this possible. Advanced metering infrastructure, or smart meters, give us real-time data and two-way communication between utilities and homes. Distributed Energy Resource Management Systems, or DERMS, help manage the growing number of resources like rooftop solar, batteries, and electric vehicles, turning them into assets that support the grid. Microgrids are smaller, localized grids that can operate independently during main grid outages, boosting resilience, especially for critical facilities. Energy storage, particularly batteries, is crucial. Storage systems soak up excess renewable energy and release it when needed, smoothing out fluctuations and providing backup. Artificial intelligence and machine learning are game changers, improving forecasts, optimizing power flow, and even predicting equipment failures. Advanced sensors and control systems give grid operators much better visibility and control, allowing faster responses to problems. Demand response programs use smart technology to incentivize consumers to shift their energy use, helping balance the grid without firing up extra power plants. Finally, grid-enhancing technologies help upgrade our existing lines and build new, efficient transmission pathways for renewable energy. By weaving these technologies together, smart grids transform our power system. They make it more resilient, better able to withstand disruptions from extreme weather or fluctuating generation. They make it more flexible, dynamically balancing supply and demand. They increase efficiency, reducing energy waste. And critically, they make our energy system more sustainable by enabling the massive integration of clean, renewable energy sources. Building this smarter grid requires significant investment, supportive policies, and strong cybersecurity. But these technologies are no longer optional. They are the foundation for a resilient, reliable, and truly sustainable energy future powered by renewables. Thanks for tuning in.